Every triangle can look different, but its three inside angles always make the same total. And this lesson will first show the idea with torn corners, then prove it with one parallel line, and finally use the theorem to find a missing angle. The key is to turn the three separated corners into one straight angle, then explain why that straight angle must match the original triangle's angles. Starting from the plan, the paper model keeps the three triangle corners separate, but still preserves each original angle. When the torn corners are placed tip to tip, their edges line up as one straight angle, so the three triangle angles together make 180 degrees. With the torn corner result visible as a clue, the proof begins by drawing a line through one vertex that is parallel to the opposite side of the triangle. This new line creates two extra angles beside the vertex angle, all sitting along one straight line. Now that the parallel line is in place, one side of the triangle crosses both parallel lines and acts as a transversal, which is a line that cuts across two other lines. The angle at one base corner equals the matching angle beside the top vertex because alternate interior angles between parallel lines are equal. With one base angle moved to the top line, the other side of the triangle works the same way as a second transversal. The angle at the other base corner equals the other angle beside the top vertex. With both base angles matched at the top, the three angles along the parallel line are the same sizes as the triangle's two base angles and its vertex angle. Since those three angles sit side by side on a straight line, the triangle's three angles add to 180 degrees. With the angle sum proved, a missing angle is found by subtracting the two known angles from 180 degrees. For angles of 55 degrees and 72 degrees, the known total is 127 degrees, so the missing angle is 53 degrees. Because every triangle has only 180 degrees to share among three corners, two right angles would already use the full total. That leaves no positive angle for the third corner, so a triangle cannot have two right angles.